So 17th question is an optical fiber question, where you have an optical fiber in which there is an inner core which is denser and outer cladding which is a rarer medium. You already know about it, and there's an axis. The light ray can be incident from the stomach, and this general angle of incidence from the stomach is going to get bent towards a normal because it's entering into the core. And here, if the angle is greater than the critical angle, then it will get totally internally reflected. And the doctor will be able to see endoscopy of your stomach or ulcers or whatever. From this time, you have R plus IC plus 90 is equal to 180, where we are assuming it to be IC, though it has to be greater than IC. So then R will be, take it that side, 90 minus IC. You know, IC is, it has to be lesser than, it has to be greater than IC. This is IC is a minimum angle. It has to be greater than IC. So the R value that you get maximum. And so from here, you know, refractive index of the core with respect to air, because the medium here is air and that's inside your stomach, and this is core, is equal to sin I by sin R, rarer to denser, where R maximum is what you're keying in here, which this means I also will be maximum, because as I increases, R also tends to increase in, so then you get sin I maximum, which is mu of core with respect, if you know the core's refractive index with respect to air, multiply it with sin R maximum that you got, you get sin I maximum. So then you already know how to get the critical angle. Critical angle is sin inverse of 1 by mu, which is core with regard to cladding, so which eventually will become 1 by mu of core, and the cladding refractive index will go up, and both of them with respect to air. Read the question and see what is IC. The outer pipe refractive index is 1.68, the inner core's refractive index, inner core's refractive index, the more the denser the medium, the more is the refractive index. So 1.44 is the rarer medium, which is the cladding, and that's a pipe. The glass fiber is 1.68. With that, you can get sin IC. And the value of this turns out to be, when you divide, it gets to 0.8 approximately, and you should know that 0.8 is always closer to 60 degree. You need to memorize this. 0.8 is closer to 60 degree. You can write sin 60. Sin 60 is root 3 by 2, which is 1.732 by 2, which is 0.8 approximately. So whenever you see 0.8, you know that it's closest. Okay, what is it? 0.8, 2 ones are 2, 6 to 12, 0.816 exactly, root 3 by 2. Whereas this is exactly 0.8571. Can you see that? This is slightly greater. This angle is, the value that you get here is slightly greater. So therefore, the angle can be, just keep it as 60, or they have just referring it as it's closer to 60 degree. So they have put this as 59 degree. Why 59 degree? They have given this, they found it actually to be 59 degree. Okay, in fact they have found it to be 59 degree. We are guessing it here. 0.8 is always close to 60 degrees. So you can keep it as 60 also, doesn't matter. So I got I, and I can substitute it here, which is my critical angle, and I get this critical angle. So R will be 90 minus 59. 90 minus 59 will be, can I say 31? 59 plus 31 is 90. So you get R, and you know this is the R maximum, 31. This has to be greater than 59, and this has to be lesser than 31. So then that's substituted here. You already know R maximum, which is 31, sin 31 degree, multiplied with mu of core, which is given as 1.68 into sin of 31, and you get your sin I maximum. And this, when you sin 31, we don't know, but we know sin 30, right? What is sin 30's value? Is 1 by 2. So then again this is 0.84. Closer to 0.8 is always 60 degree. Can I say that I max also is 60 degree therefore? And so this is max, which means the incident angle can be ranging from 0 to 60 degree. If critical angle is, so can you see the interrelation? The critical angle is 60 degree. It eventually boils down that the angle of incidence at which from the stomach it's coming can range between 0 to 60 degree, but though this has got nothing to do with it, the additional steps are involved. So, but I can say that your R is 31. Your R is 31. So let's keep this as 30, or 90 minus 30 is 60. So your I can range between 0 and 60. This is something that you need to get it very, very clear in your mind. They will ask you as MCQ. So if you know your R here is 30, obviously your I will be 90 minus 30, which is 60. It's easier to say. But however, you will not know that it has to range between 0 to 60 because it's I maximum. 60 is your I maximum. I hope you understood. Let's go to the next question, which is the 18th question. Sorry, the 18th question is where the image of a small bulb in one of the wall is getting formed on the other wall, and so it can be inverted, the bulb inverted or erect, we don't even know. So then by using a convex lens, they're asking us to do it. We can say at C means the image will also be at C, so which is 2f plus 2f, and they've given the distance between the two walls is 3 meters. 2f is plus 2f is equal to 3, 4f is equal to 3, f is equal to 3 by 4, so that completes 0.75 meters. That is the focal length of the convex lens. We found it. Okay, so let's go to the next question, which is the 19th question. Sorry, it didn't get recorded. I recorded earlier, so now I have to record it. So 19th question, let's read the question once again. A screen is placed 90 centimeter from the object. So this object, the screen is placed 90 centimeter from the object, and the image is formed on the screen at two different locations of the convex lens. At this location initially, and then I'm also shifting this lens here, yet I'm getting the image to be only here. There's no image is always here. In that case, we should understand that the distance between the two positions that we are shifting is given to be 20 centimeter. You have to assume this as x and this as x. Why? Because let's consider this like for the first lens. Let's take the first lens. For the first lens, you know that your object distance is minus x, and the image distance will be 20 plus x. This for the first lens. If you consider second lens to be there, that is shifted. That's not second lens. For the first position of the lens, the second position of the lens, your object distance will be 20 plus x, and the image distance will be x. So therefore, you understand that x plus 20 plus x is equal to 90. At 2x plus 20 is equal to 90. At 2x is equal to 70. X is equal to 35. Substituting back in one of the equations. One of the lens formula, sorry. So let's take the first position of the lens. You want to find the focal length of the lens. 1 by f is equal to 1 by v minus 1 by u. For the first position, u itself is x, so minus 35. So it will become 1 by 35. And you know the v is 20 plus x, so then it's 55 is equal to 1 by f. And so when solving this, you get the focal length to be 21.4 centimeter. You can take the LCM, which is 385 and 7 plus 11, and then reciprocal those values. So you get 18 by 385, and reciprocaling that is 385 by 18, and you'll get this as a focal length, and that's another sum. Let's go to 20th question. 20th question, determine the effective focal length of the combination. In continuation of the question number 9.10, in the 9.10 question, you have a convex lens and a concave lens which are placed close to each other, and eventually it turned out to be a concave lens because the focal length, the effective focal length became minus 16. The focal length of the first lens was 30 and the second lens was 30, and the second lens was 20, which we had to take it as minus 20. Remember the sum. Now you are placing it with the spacing between them. In this case, the distance between the two is 8 centimeter apart. An object is so first part of the question, they are placed 8 centimeter apart, and a parallel beam of light is incident on the convex lens. The object is infinity. Image will be at the principal focus. The principal focus of the first lens, convex lens, is 30. Therefore, you can imagine this is going to be converging somewhere behind, and the total distance is 30. And subtracted from 8, 30 minus 8 is 22, becomes your object distance for the second lens. This is going to serve as an object for the second lens, and so it's positive also. U for the second lens, and you can take the second lens and write 1 by f is equal to 1 by v minus 1 by u, where the focal length of the second lens is minus 1 by 20 is equal to 1 by v. You don't know, but you know the u is positive 22, and so the minus stays there. 1 minus 1 by 20 plus 1 by 22 is equal to 1 by v. So you can take an LCM here, which will be 220 is the LCM. So you get a minus 11 plus 10, which will become minus 1 by 220. So V itself is 220. Where is 220? And it's also negative, which shows that this is a diverging lens, which would have diverged and your final image can be obtained somewhere so far away at a distance of 220, and that's based on the second lens. So you can subtract it from 8 in order to get it from the first lens if you want. So that's about this, and so then so 220 is the answer. It's 220 centimeter. Let's go to the next part of the question. Oh, then does it make a difference if the light ray is going to be coming from the right side? It's infinity. The focal length of the second lens, that's concave lens, you know, is minus 20. So your image will get focused at minus 20, because 1 by f is equal to 1 by v minus 1 by u, where the object is at infinity. V will be equal to f, and f is negative, v is also negative, which shows that your first image is going to be obtained to the left side, and that is, this is 8, so it's going to be obtained somewhere here, minus 20, and that will be your image of the second lens, and that's 20. And let's take the magnitude and subtract it from 8. 20 minus 8, so this object distance will become 12. So that's your object for the second lens, and second lens has got a focal length 30 is equal to 1 by v, we don't know, but you know 1 by u, which is negative, which is minus 12, so plus 12. So 1 by v is equal to 1 by 30 minus 1 by 12. Can I write 60 to be the LCM, and 2 and into 5, and 2 minus 5 is minus 3 is equal to 1 by f. So it's f is equal to minus 20 centimeter. What? This is V is equal to minus 20 centimeter. What is the meaning of minus 20? It's going to be somewhere behind only. But as compared to the 220, this is much better. It's much closer. Correct? So you got your V to be minus 20. So the question is, is it going to affect your answer by does the answer depends on which side a beam of parallel is incident on? Yes, the answer definitely changes. And this is the way I have done. I have not understood what Arora has done, but for me I understood the question this way only. So let the parallel beam of light be incident from left on the concave lens. Oh, I have taken it from the right on the concave lens and have done the sum. So they are saying from the left of the concave lens, which means does it mean the concave lens is on the left side? And I think they have interchanged the lenses. Let's read the question again. Does the answer depends on which side a beam of parallel light is incident on? I think they have exchanged the position of the lens itself. What I have done is considered it from the right side, but that's not what they are asking you. They have asked you to consider that the first lens is a concave lens and the next lens is a convex lens. You know, this has got minus 20 and this has got 30, and so then object is coming from infinity. You know that it will appear to diverge and it will appear to come from a point which is minus 20 on the left side only. So you already have a distance between the two, which is given to be an 8, correct? An 8 centimeter. So this 8 and 20 has to be added together. So minus 28 when compared to the second lens, the object distance is minus 28 will be the object distance for the second lens. And so then for the convex lens, you know the focal length of convex lens is 1 by f by 30 is equal to 1 by v Minus of 1 by u is 28, so 1 by v therefore is 1 by 30 minus 1 by 28, and so this will turn out to be 420 is LCM, 14 minus 15, which is minus 1 by 420, so v itself is minus 420, which shows that it's going to be further away, like it's going to be farther away for the because it's negative, that shows that the image is going to be on the left side only. So definitely it does affect your answer. So basically in this question, if you see, this is because the parallel beam of light appear to diverge from a point. The fact that you got a negative V, and there again you got a negative V in 216. Okay, there again you got minus 220. Let's ignore this. This is something unnecessary that I've done. This one is fine. Okay, this one is fine. The red color thingy that I wrote, that's not valid because I'm considering from the, I didn't exchange the position of the lens. That's not what they're asking. They're asking literally to exchange the position of lens. This is minus 220, whereas this is minus 420. So when it is minus 220, they are saying that from exactly at the center, this distance is 8, exactly from the center 4 is where it's actually appearing to diverge. The parallel beam of light appears to diverge from a point exactly from the center of the two lenses. So then therefore this distance is actually 4. Okay, and when you get 220 to be this distance, minus 220, since it is starting to diverge from here, you have to take the minus 220 is this distance and this 4 is this distance. Take the magnitude of it and then subtract it so that you know from the first lens what is the distance. So then it will be 220 minus 4, which is 216 centimeter from the to the left of the first lens. Oh no, actually the fact is the second lens length, the whole distance is minus 220, correct? From the second lens the whole distance turned out to be minus 220, and we have to find from the midway between the two lenses only. We don't need from the end because the midway is the the origin. So then therefore they are subtracting, they are taking away a 4 from the 220 and saying that this distance is 216. From the center of the two lenses is the distance they are asking, then you have to subtract. So here again you have to do the same thing. You got 420, then you have to take it from the center of the lens, 420 minus 4, and that's where it's appearing to diverge again. So that's clear. And determine the magnification produced by the two lenses system. Magnification produced by the two lens system. So clearly the image does depend on which side of the lens. The lens is on the left. The first lens is convex, the second lens is a concave. They should say that. That is not clear. Depends on which side of the lens system the parallel beam of incidence. Instead of saying like that, they could have told us to interchange the position of the lens. Then the answer would be clear. So there's another question where the height of the object is given. The height of the object is given to be part 2, 1.5 centimeter in size, is placed on the side of the convex lens, the above arrangement. The distance between the object and the convex lens, which is 40. The object distance is given to be 40, which is minus 40 centimeter. Determine the magnification produced by the two lenses. You find what is, the focal length of the convex lens is 30. So using that, you find 1 by f is equal to 1 by v minus 1 by u, where it will become plus 1 by 40, and this will become 30. With that you can find what is your v of the first lens, that is convex. That's what they are referring as 1. So you get your v1 to be 120 on solving this, and once you get that, you got your object and your image. The magnification produced by the first lens is m is equal to v by u. For a lens it's always v by u only, for a mirror only is minus v by u. So 120 by 40, the magnification is 3 times. So if the object is so v is equal to 3u, your object height is 1.5, the interim image will be 4.5 times, correct? Are they asking for that? They're just asking only for magnification. This another part of the question, such a lengthy sum. The distance between the object, determine the magnification and the size of the image. Yeah, they have asked for the size of the image. Probably they're asking for the size of the final image, not the interim image, because this is only the magnification produced by the convex lens. Now come to the concave part. You know that V1 is 120. You have to take this 120 and subtract it from 8 to get the object distance for the second lens. The object distance for the second lens is 120 minus 8, which is 112, and so you can write the focal length of the second lens, which is a concave lens, which is minus 20, is equal to 1 by V minus 112. It will be on the right side, so plus 112. So 1 by V therefore is minus 1 by 20 minus 1 by 112. The lens formula itself has got a minus, and 112 itself is positive, so when it becomes with a plus, and 1 by V is equal to, when LCM is itself is you solve this, you get the answer V to be 24.9 centimeter. You can refer Aurora. Okay, just multiply these two and then solve it. You get 24.9 centimeter to be your V2. So magnification produced by the eyepiece, or in other words, second lens. Okay, not eyepiece. So it's height of it's nothing but V2 by U2, which will be 24. What is the value of this you got? V2 you're getting it as 24.9 by U2. The object distance is 112. So then you got your total magnification is M1 into M2. We can treat it as an objective and eyepiece, similar to that, but it's not similar because you have a convex and a concave. So just a comparison of these two, so you understand it's M1 into M2. Just multiply these two values and you get 0.652. Such a beautiful sum. And this is the total magnification, which is nothing but height of the image by height of the object. Height of the object is 1.5, with which we have to find height of the image, where you substitute 0.652 here. So that's very, very complicated. So you have to treat it like a compound microscope, something similar to it. Okay, where M is equal to MO into ME, here is M1 into M2. So let's go to 21st question. At what angle should the ray of light be incident on the face of the, so there is a prism, which is angle of prism 60 degree. So that suppose total internal reflection on the other face. If it has to undergo total internal reflection, this is the ray, this is the normal, it's going to bend towards the normal, it's going to undergo total internal reflection. This angle has to be critical angle. You have to do a normal here, and this angle has to be equal to critical angle for it to graze through the separation. For total intrusion, it has to be greater than critical angle so that it gets reflected back. And you know that if this is the way it's going to go, the angle is 90 degree. Which angle is this? The angle that this is the critical angle. If this is the critical angle, this is going to graze through separation. Your R gets to 90. Can you see? Angle of refraction is 90. This is angle of emergence is 90. Can I say angle of emergence is 90 degree? This is R1 and this is R2. R1 plus R2 is simply A. So you know that R1 plus R2 is equal to 60 degree. And what have they given you? Have you found the critical angle? For the critical, this has to be critical angle. R2 itself has to be critical angle, IC. And IC is equal to sine inverse of 1 by mu, which is refractive index of the glass, which is sine inverse of 1 by 1.5 or sine inverse of 1 by 3 by 2 by 3. And 2 by 3 is nothing but this value. What is 2 by 3? Let's sine inverse, keep the sine inverse separate, 0.20, 60 is 18. It's not 0.8 for you to assume it as 60 degree. So then the answer for this is actually 41 degree. It can be 45 degree provided it's 1 by root 2. Okay, so you can check out what is 1 by root 2. 1 by root 2 is 1 by 1.414 and divide and see. So therefore here it's an unknown angle, which is 41 degree. Once you know this is 41 degree, substitute in R1 plus R2. R1 plus R2 is equal to A, which is 60 degree. R1 plus 41 is equal to 60. So R1 itself is 60 minus 41. 60 minus 41, can I say is 19 degree? And that's about it. R1 itself is 19 degree. What are they asking? At what angle should the ray of light be incident? You know R1, which is this. They are asking this angle. It's sine mu is equal to sine I by sine R1. Sine R1 itself is 19 degrees. Sine 19 you should know. We don't know. But if you know, then you can write sine I is equal to mu into sine of 19. Refractive index of glass again is 1.5 into sine 19. If you know sine 19's value, then it becomes easier for us to do this. Otherwise not. So that's this, and let's go to 22nd question. A card is divided into squares, each of size 1 millimeters. One card is there, it's getting divided into small squares. Each square is 1 millimeter square. Is viewed at a distance 9 centimeter from the magnifying glass. The converging lens has a focal length 10 centimeter. This is negative always, u is equal to minus 9. What is the magnification produced by the lens? How much is the area of the square? K, increase and all that. Okay. So you know the focal length of the lens 1 by f is equal to 1 by v minus 1 by u. 1 by 10 is equal to 1 by v plus 1 by 9. So we can calculate what is 1 by v. Therefore v is found to be minus 90 centimeter. Once you get your v, you know that magnification is for lens is v by u, which is also equal to hi by ho. Okay, coming back to what is v is 90 by u is 9, so it's 10 times magnified. The 10 times is magnified is only the linear magnification, not the entire area. But here the question, they have given area 1 millimeter square. So what's 1 millimeter into 1 millimeter is 1 square. So the height of 1 square, just the side of 1 square is just 1 millimeter. So 1 millimeter is going to be multiplied 10 times. So it's going to become 10 millimeter is the linear magnification, not area magnification. But if they ask you area magnification, yes, in that case, you know, it's 10 millimeter into 10 millimeter. So it will become 100 millimeter square. 100 millimeter square or 1 centimeter square becomes the area magnification. So depending on whether they are asking you linear magnification or area magnification.